Hello, everyone. We'll get started in just a second. We are just making sure that we have a few folks joining. So we have 1 hour for this session. Can everyone see my screen okay? If you guys just do a thumbs up, I know you guys can see the slides and hear me okay. Everyone hear and see? Perfect. Thanks, Victor. All right, we will get going then. So today we're going to talk about getting started with AI in testing for test engineers. And my name is Jen Bodine, and I am the CEO and founder of the AI App Store and RedRex, which is a platform that leverages artificial intelligence and machine learning to assist organizations in terms of building digital spaces and digital buildings. So many of us over the last year have had to go distanced and digital with our companies, and we build those buildings that help you no matter where your team is and when you're distanced in those spaces. So just a little background on us. I have two co-founders with me that helped build the organization. Andrew Burkholz is our Chief Technology Officer. Rick Felice is our Chief Operations Officer. In this space right now, AI is incredibly interesting in some of the decision-making and the points that we have to make as technologists as we're building this technology. We consciously chose in the tech that we're building right now to go for the direction of humanized AI solutions. So there are different approaches people are taking in the AI space, but the one that we have focused on and have taken up is humanized AI solutions. And what that really means is focusing on what people and humans do well and what machine learning algorithms do well, so that we build solutions that pair humans and machines together in a positive way. We did this originally in the gaming space. So we were doing a lot around game companies, solving some of the challenges in that space. And as I mentioned, now we really work across all verticals, building digital schools for people in places where they're distanced from physical school buildings or don't have the opportunities to go to those schools. We can now connect them digitally to a digital school where they have more opportunity. So we really focused on the social impact of the AI that we're building, and then we're generating revenue after that. What we'll be talking about today is what is AI? So I want to go through some of the terminology because it gets really confusing sometimes around what do we mean when we talk about ML, what is deep learning, what is AI, and what do those terms mean? So we'll go through that for you. We'll talk about some of the challenges around why you would actually want to utilize AI as another strategy on top of, say, intelligent automation or other strategies that you're using inside your engineering teams. We'll talk about different approaches to put that into play, and then some of the skills that you're going to see as critical. So we are seeing a shift in different skills, and a lot of this has to do with these new technologies that are emerging that are going to make a difference in how we work with organizations and how work gets done, what types of technologies we're using to do that work inside of organizations. And a lot of this is based on different data sets, and we were seeing throughout the pandemic has actually accelerated. And I'll give you some resources that show we've actually accelerated during this last year, a little over a year now, year and a few months, the utilization of machine learning and AI based on everything that's happened across the globe. It's actually accelerated. So when we talk about artificial intelligence, just to baseline it so we all have the same understanding, I like people to have basic knowledge of what it is. So artificial intelligence, when you break it down, is intelligence demonstrated by machines in contrast to the natural intelligence that's displayed by human beings, so us. And what it means is we have machines who are demonstrating this intelligence instead of human beings doing the thinking and the processing. And then when we talk about ML and what that looks like, so machine learning, then in contrast to artificial intelligence, is a field of computer science where we are using techniques to give computer systems, quote, the ability to learn with data without explicitly being programmed. Now, for a lot of you that may be in test engineering who do code-driven automation, where you're writing code that then produces an outcome, I call that the one-to-one, where we're explicitly programming or telling something to do something. When we're using ML, what we're using is the ability to train or learn based off of patterns and data. So for example, in machine learning, when we're talking about automation using ML, in the case of, let's call it a website, in that website, if I were to automatically check for different values or fields on that website, I would explicitly program, if I was writing automation, or tell it, look for the price field at this point on the screen. I would program it and say it's going to appear here. With ML or AI, what you're doing is you're saying, we need to find the price field, but the price field may be in the top left, it may be in the bottom right, it could dynamically move, and we're still going to be able to find it. We're just looking for that price field, and it may not be located in the exact spot that it was last time. It also could be that instead of a distinct image, so this picture that you see here on the screen, it may be a slightly different version, but as long as there's a picture, that constitutes a positive find, right? That we found an image, that image may shift. And we do this a lot on websites. If you think about Disney Plus as an app, they rotate the image that you see. You can have different options for your profile. That all can be handled through ML to just find the pictures that fit the requirements, versus when you're using traditional automation, you would need to tell it explicitly what to look for. So a different way that you're looking at how that action is done and how that training is done without the explicit programming. The other thing to note, if any of you have worked with ML and creating the algorithms that are utilized, is the fact that it's a lot less actual code. So the amount of code is incredibly less in these algorithms that you're leveraging than what you see in traditional coding or automation. So it's not as much about how much code you actually need to write to achieve the outcome. It's about the way that it's trained and the access to the data and the data sets you need to train the algorithm. So hopefully that's making sense so far. Let me know if you guys have questions. I like to put things in pictures. So when we look at a picture of how this actually works, what you see is the AI is the bigger picture. So you hear the term AI used a lot, and I'm going to go over a couple different types of artificial intelligence just so we understand the different forms that it takes on. And then machine learning, which is that field of computer science and training or learning that sits inside of AI that does the heavy lifting on the training. So another view of this, if we position it in the picture, is AI is the bigger bubble, right? That encompasses many different types of AI that we'll go over. Machine learning is the algorithms inside of that we're training. And inside of that is deep learning or deep insights that we can get to eventually when we're doing this work. Okay. So as you hear those terms, think of it in terms of this picture of how to think about how it all fits together as you get started. Now, there's broad categories of AI. So when we talk about these broad categories, the one that is most prevalent right now when people are speaking about AI is what we call artificial narrow intelligence. So what we're talking about there is it does a particular function, right? So narrow AI says that if I'm doing training, And I train, as we've seen in the past, right? So we've all heard the stories of being able to train something to be able to perform or play chess, right? So if the bot performs or is able to play chess, narrow AI is it's able to play chess. Now, if we were start to move into general AI, this is where something can do multiple functions instead of just a single function. So this is more complicated. This is less of this in the world today. This is what we start to see in movies. So generalized AI and artificial superintelligence, these are the things we start to see when you see movies or fiction based on where people foresee this going. Once we're able to create these robots and algorithms that are able to do this, we're moving from single task functioning to generalized functioning, where instead of just playing chess, with that same learning, it takes those learnings and now it's able to apply that to Monopoly and other games as well, besides just chess, where that learning would now apply to multifunction. And then super intelligence is a whole nother level on top of that, where it starts to replicate thought and rationale and problem solving and thinking, similar to what we as human beings do, of situational analysis and awareness, and using the learning and patterning to make situational based decisions using the data and information that it has. So what you're talking about is when you look at how this operates, right, is we go from narrow being reactive. So we're patterning something. Once it sees a pattern or is given data, it gives us an answer reactively. Then we start to move into limited memory, where we're able to use those memories and those patterns to apply it to other areas. Then you start getting into theory of mind, and then eventually into that self-awareness, where it self-aware can make different determinations and decisions, more similar to like how we do as conscious human beings. So that's kind of the progression that you see. And when you start to talk about what does the future look like, and what do humans do, and when do bots take over, and what is the future of that, this is what people are talking about, is moving through these levels of narrow to this generalized and then to super artificial intelligence. And then if you guys have questions as we're going along, I'm going to check the chat too. So stop me if you guys have questions or thoughts or need me to clarify something as I go through. And I'll try and leave some time for questions at the end as well, just in case there's something I didn't clarify. So if we break this down a little bit further, of the 3 stages of AI, if you're looking at getting started inside your organizations of where you can apply this, narrow AI is dedicated to assist with or take over a specific task. So this is where we're seeing it in testing, looking at it to do specific tasks in that testing, where we ask it to do things like do an app graph. So crawl across my mobile app or my website and look at everywhere a field is utilized. So the login field, go check everywhere login is utilized. And anytime that changes, or we add a new place where login is used on the app or the website, inform me and give me that change, so I know that there was a change and logins now being utilized in 2 other places. Or if there's a brand new field I wasn't expecting, let me know that there's a new field that was developed that's being utilized on the website. So that task of checking and validating for different fields on a page or in a mobile app would be a specific task that it could do for you. The other things it could do is validate. It does different diffing, right? So validate different visual diffs that you see on a page. So did this change from one image to another? Did something occur? Did we get someone who put something on the site we weren't expecting? That's visual diffing. That can be done by narrow AI. If we move into general AI, And that's where I mentioned taking and transferring domain knowledge from one area to another. So we were using it to do chess and play chess. And now I'm transferring that to not only doing chess, but I'm playing checkers and Monopoly and all of these other things based on the information and knowledge I'm gaining from being able to know how to play chess. Or you think about, instead of running a particular portion of your vehicle, so now in a lot of vehicles, they may not even tell you, but vehicles are reporting data back to the car manufacturers. Anyone in a new vehicle, if you've driven a new vehicle recently, seen where sometimes your vehicle will say things like, I suggest you take a break. What it's saying is you're following too closely. It's watching the patterning of how close is your car to the car in front of you, because it can tell that distance. And then it's sending data back saying you're following too closely. You need to create more distance between you and another vehicle. Or it can do things of, you accelerate or use high volumes or high speed in certain times of the day. All of that data being gathered is patterned and then can send information back to the vehicle to give you directives as the driver in single stages. But now if it took all that data and automatically had the acceleration decelerate, or if it did patterning on your behalf, we're starting to generalize and do multifunctioning inside of that vehicle and transferring that domain. And then super AI, this would be an order of magnitude where it's smarter than us as humans, right? Not only can it go across large volumes of data and pattern data sets, but now it's doing super intelligence and rational thought and problem solving like we do, where we take into account nuanced information to make the decision instead of just the data we're given. So when we give narrow AI data, it's literally looking across that data and saying, what is the pattern and what would I predict is the outcome, looking across hundreds of thousands and millions and billions of rows of data to come to a conclusion. But then we as human beings look at that and say, oh, that's not quite right. That is how we've done it in the past, but we didn't take into account this new piece of information we were just given. It doesn't do that yet. Once it does that, you're getting to that super AI, where now it's taking in not only the patterns in the data, but an order of magnitude of being able to create rational, realized thought on its own and developing its own patterns of thought. Now, AI has been around for a while, and that narrow AI when we're talking about it. So it actually was in the 1980s when you saw this inside of universities. It was mainly large scale universities and big corporations that had the access to the compute and the amount of capacity to physically run AI and the algorithms and the amounts of data and process that you needed to run to be able to have those models being built. So that was in the 1980s and 90s. So it's been around a while. This isn't new. It's been something that people have been working on for a long time. Why we've started to hear more and more about it, and it's come more, I would say, to the forefront and people talking about it in everyday life, is a couple of things happened. So what started to happen is compute got a lot cheaper. We've seen us go from in the 1980s to supercomputers that took up entire storage rooms and facilities, now to being able to condense that down into very small amounts of space where you can run mass amounts of data and volumes of data. If you look at the compute power on the average PC that's in the hands of home consumers and the price drop that's occurred on those, that is one of the big factors in why AI is much more prevalent than what we saw years ago. It's because there's more access to that compute. It's cheaper than it's ever been for us to be able to get access to it. The other thing that's happened is with access to compute, more people are building more neural networks, which is netting out new approaches to how you build data sets and models for AI. So more people involved means more diversity of thought in how those models are being built. It also means there's a lot more startups and companies outside of just big, large, well-funded universities and large corporations that are able to experiment and play with AI and get it out to the market space so more consumers are able to utilize it. We've also got, just like with what happens all the time as we see, instead of just pay for products and tooling, you're seeing a lot of open source models that have been started and developed that now more people are able to access. So when you have access to open source, more people can now take and leverage and utilize a base, so they're not starting from scratch. They can take an already developed open source model and extend it. That's another piece that's happening right now. So this gentleman is the CEO of NVIDIA, and he talks about where we're going. So when you think about it, the comment's been made that software is eating the world. If we look at how much software is utilized today, we all have devices we use that have software and apps. Think about what would happen if you couldn't use software or apps to purchase things online, to order food every day, to get your Ubers or your Lyfts, to be able to get your hotel accommodations, your rental cars, your flights, any of those things. Most of the time, all of us depend very heavily every day on lots of software to drive our everyday actions, from our buying habits and patterns to the work that we do, to our email, to everything that's happening in our lives. So we are heavily dependent on software. So that's why they say software is eating the world, because it's everywhere we turn. And when software fails us, or when software doesn't work, we have a huge implication. So there's a question too. So Lloyd asked, and I'll look at this really quick and then we can talk about it when it makes sense. The question was, do we see automated testing using more AI in the future and moving away from the current practice of heavily coded scripts requiring knowledge of programming languages like Java? That's a great question. So we're going to get into this, of what I see and some of the patterns in terms of that. I think the first phase you'll see of this is going to be as we transition from software being the predominant thing, AI will actually be what becomes predominant. It will eat software, and AI and models will be more what we use than just heavily coded software. It'll actually be these algorithms and models that drive the behavior, the patterning, and how we operate and move around. But it's an evolution process to get there. It's not going to happen overnight. And I'll actually give you some stats on how much changes and when that kind of changes as well. But that's a great question for what we're seeing. Now, here's some of the problems it can assist us with. So when we look at, Gartner does surveys and studies of executives of what's going to change the game in terms of companies and where they're going. The big game changers people are looking at, by far, it's not even a close contest right now, is AI and machine learning. So leveraging AI and machine learning to do some of that, at least reactive, if not starting to get predictive of where to go, how to help you with determining consumer patterns. I'll talk about where it is good and what it's helping companies do. But what comes with that hand in hand is data analysis. So a lot of what we're seeing in companies is the pattern in your teams to be adding data scientists or data analysts into your organizations, in your tech teams, so that those data scientists and data analysts, as you start to use more AI and ML, can be leveraging that knowledge of those technologies with the data it's producing. So once you start using AI and ML, the vast amounts of data that you start producing around all kinds of information grows exponentially. So it becomes a need to figure out strategically, what data do you pay attention to, and how do you quickly analyze data to make more rapid decisions and get you to product decision making, consumer reaction, how to get from the idea of idea to implementation faster. So how do you shrink times for implementation, even those types of things? So AI and ML is definitely where people are focused right now to get strategic advantage in companies. So where AI can help us, I mentioned it a little bit in the beginning, but it does some things really well. So if you break it into 4 basic classification types: text, image, video, right? So if we look at some of these, it's really good at these, and audio. So if you are trying to compare text and you're trying to say, what did the site or the mobile app look like prior to now, and diff those two things, it does it incredibly quickly and incredibly accurately. When we as humans have to process through mass amounts of information and data manually, so this is a case where if you were to have to do some of these things manually, not only would it take a very long time for a human being to process, we have the ability to get fatigue. So we as humans, our eyes fatigue when we look at something too long. Think about how many times we've read through an email where we're going to send this email and we've read it, 50 times because we want it to be perfect. We send it out, and the first time we send it out, someone else notices an error right away, and we completely missed it. Because the way our brains work as humans, we work on patterned information, but we skip things that we don't think belong. So we can read 2 thes in a sentence and skip right over that second the, because our brain automatically deletes it. That's how we work. It didn't belong, so we deleted it. Someone else, when they're looking at it fresh for the first time, sees it and picks it out as an error. Machines will always pick those out as errors. They're very accurate when you give them specific tasks to perform, to compare one thing to another, to pick out when something isn't correct in large mass volumes of data. Same thing as I mentioned on image diffing. So it's able to do some of these things really, really accurately. It can detect janky frames in video. It can detect glitching. It can detect nuances of, the image where in a video game, for example, the foot was just a fraction off of where it should have been. We can't create those fractions of pixels. Human eyes has a hard time detecting fractionality of pixels on screens, where AI can pick that up right away on that positioning, right? Same thing with a lot of our traditional automation. The fractions and the pixels and the explicit programming works really well for these types of functions. And then audio differential, where the audio isn't matching, those types of things it can do as well. So it depends on what problem you're trying to solve to what you should use as the tool to solve that problem in your testing. And that's where, how I think of it as, if you think of it as layers in our testing, we have human beings. Human beings can do things that machines can't do right now. That's without a doubt. There are things our brains can rationalize and do and process that we can't explicitly program through coding, and that we don't have AI and ML that's able to rationalize through to do those things. So there are very distinct things. I would say if you were to do a hierarchy of the technologies and the tools you have available in your toolkit for testing as organizations, you should always, in my mind, think of human beings as the most valuable resource that we have. We are the most expensive, and we are the most valuable in terms of the functioning that we can do. We are very high functioning for most of us. You can function at a very high level. And we're the most expensive because we pay human beings a certain amount of money. Human beings need to sleep. We need time off, those types of things. When you get to coded, you need humans to do the coding, right? So there's a time investment of human beings to do traditional or intelligent automation that you're utilizing, and that coding needs to be maintained. So it's a one-to-one. We have to write the code, and then we have to maintain the code as the application and the product changes. You have to update that code. It doesn't dynamically change with it. There's inherent changes you have to explicitly program or code or make changes to. So the things to utilize traditional automation with our intelligent traditional automation would be things that are fairly stable in the system, right? So you're looking at API integrations, you're looking at database type things, you're looking at things that are very stable that you want to code in and make sure that you are able to always check and validate that those things are working routinely and quickly, because you can code for them to do that a lot faster than a human being can manually do that work. So you want to use those things for that. And now with AI, what we have is AI learns off patterns. Much less coding, isn't as explicit. You can train it, and you can train it to do not just one thing, but like I mentioned in AI, if I train it to go do an app graph and look for these fields, it's going to go look to see where they are, even if they move. So if you're making dynamic changes to the app, that AI is still going to go look for it and tell you where it moved to and ask you, is that correct or not? And if you say, yep, correct, it will keep going. So it has that capability to go beyond explicit programming. And there are very distinct things it does well. This will change over time. It'll get more mature in that and move from that narrow to a more generalized inference of, I know how to do this type of application. Now I'm going to move that knowledge over to this application. So that's where it will go over time. So starting with that is a good thing to get started in an area where it can add value. So here's the different types of AI that we can use. Sentiment analysis. So put in the chat if any of you in your companies are using AI to do sentiment analysis across ratings, reviews, your customer feedback, risk assessment, suppliers, any of that stuff. If you're doing that, put it in the chat so I can see if anyone's doing that today. Your business groups may be doing it, maybe you don't know, but a lot of companies are doing this today. This is a smart place to start your utilization of analytic AI, where you're starting to reach out using algorithms and bots, grab data, pull it back, and then make some determinations based off of that data. I'll give you an example. If you want to know what your customers think, and a lot now of, if we look at the World Quality Report that talks about surveying across the globe, what is the state of the world for quality and where does it land in companies? One of the things we see is the primary function that executives want quality or testing to perform for them is the concept or idea of customer satisfaction. We want QA to assure that the customers that we have are satisfied with the products and services we're producing. So that means that sometimes things that we produce or put out, especially in startups or new products, are technically defects, like they're defects against the requirements. It's not how the requirement was written, but it went out to the world. But now the consumers that took that product actually like it the way it is, right? They like that defect that wasn't the requirement, but they want it to stay the way that it is. The idea is that QA should understand that the consumer prefers it the way it is and not to change it back to fit the requirement, but to keep it as is to satisfy the majority of the customers and maintain customer satisfaction as well as market share. That's what the World Quality Report showing is the trend, that executives believe QA's job is to ensure customer satisfaction and ensure keeping and retaining revenue, which means retaining customers. So one way to do that is through the sentiment analysis or risk assessments. Analytic AI would go out and it would literally have bots that go look for anywhere someone makes a comment about your product, service, app, whatever it is that you have. It would pull back all that data. So it could be App Store reviews, it could be reviews on Facebook, it could be reviews on social media, it could be reviews that you calculate and pull in on your websites through a review form. Wherever that data is stored, it would go dynamically out to all those places, grab all that data, pull it back, analyze it, and then tell you what people think about your product. So it's basically giving you a review of that product. And then it's going to go through and create sentiment analysis, which gives you trending to say, is your sentiment over time trending positive or negative for your product? Are you getting better or worse? And the reason that's important is you can then start to correlate from the time you make a product enhancement or you change something in the product and you release it to the world. How long does it take from when you make that change to the sentiment to reflect that in your consumer reviews? And that's a powerful tool for companies to be able to know, if I make this change within 2 or 3 weeks, I'm going to start to see either better customer reviews, more customer feedback, more referral customers, whatever it is, to grow increased revenue. So testing organizations in the future, I believe, will have more AI based in this space where you're helping gather that sentiment analysis and giving that feedback on where to make changes and what strategic product changes need to be made. The next one is functional AI. So these are IoT solutions or robots. They're the types of things we see right now with smartwatches, smart devices, smart clothing, where it's gathering a bunch of data. A lot of retail companies right now have started purchasing things like Peloton bikes and interactive mirror walls, interactive weight systems. What they're doing is they're getting all this data on people's habits and patterns of how they work out, what types of workouts net out better muscle resistance, what types of workouts are netting out better returns on building muscle, those types of things. Then companies are taking it to the next level. If while I work out and I'm a retailer, not only do I also own some of the in-home technologies that people are using, but if people now wear devices or clothing that has AI sensors, so sensor-based clothing that tells me what does my range of motion look like. I can recommend to people when they work out a different form or a different way to do it, or different types of cooling, right? So you need to wear clothing that actually reduces your body temperature or increases your body temperature through these sensors that are placed on the clothing itself. Next piece is interactive AI. So these are chatbots, personal assistants, smart assistants. Lots of us have interactive AI in our homes. It was said that through the pandemic, one thing that's increased is those interactive AI voice assistants or smart assistants that most homes have one, if not more, in their home that they engage with to ask questions and get information. The next one is text AI, where it does text recognition, speech to text conversion. We are seeing some of this on the assistants. So anyone utilizing any of those AI assistants where they listen to your meetings, they sit in as one of the meeting participants and they do text translation. So they hear you talking and they digitally take notes for you. It's voice to text note takers. You'll start to see like so-and-so's bot has joined the meeting and they're there to take notes and basically do this, convert speech to text. That's happening a lot. Chatbots are also really prevalent. A lot of times when we're interacting or engaging with companies, what we're doing is we're not talking to people, we're talking to chatbots who've been programmed different responses depending on what we're asking them. And then visual AI. So you see a lot of companies in this space where they're doing computer vision and augmented reality, where they're doing visual compares of computers looking at different images and telling you this is the same thing or this is a different thing in terms of the computer. So these are, again, just to drill down of where you could start leveraging AI. Many companies have started in the sentiment analysis realm. They may have some IoT devices or robots. Chatbots and smart personal assistants are utilized in almost every retailer services company now. These voice bots or text recognition is another piece where you're seeing it come up. So moving on from there, this is where we start to see why in our space in testing, we've got to do something different. The complexity we're dealing with is massive. We don't have the capability to manually check and cover everything that's out there right now and get the speed to market that's being demanded. Everyone wants everything out in the market faster than ever. So the only way we're able to scale and do some of this is by taking on some of these new strategies to become our virtual assistants to basically help take on some of the tasks that aren't as value add for us as human beings as the most expensive resource to do those tasks inside of our teams. So what I would say is, here's some of the things, if you're facing these as challenges, to strategically look at how you start putting AI in to assist you as one of your tools, in addition to automation and other things. But scale. If you're trying to scale and do more work than you already have on your plate, AI is a good way to assist in scaling. The other thing is product decisions. If, as I mentioned, through that sentiment analysis, you can actually help make decisions on which way to go with the product that better predicts how it's going to impact your consumer and actually net out better revenue for you as a company. It allows you the capability to not only right now for automation, we do a lot of automation on our own products to check and validate that our products are working as designed. We can automate checks for performance, stress, load, volume, those types of things, security verifications, all those types of things. We're looking at automation internally for our own products. But one of the things that AI allows is creating a framework to check not only your product, but competitor products. So imagine now being able to use one framework that you have in a set of machine learning algorithms and bots that checks your site, but it also checks your competitor sites. As long as their data is publicly available, this is possible and you can do it. It also can help you generate test data for different scenarios. One of the challenges we usually have, I know in many companies, is test data to be able to run all the testing scenarios. Utilizing AI to build and develop that test data, another really important thing that you can do. And then production alerting to run constant validations and checks to see if anything has changed in production, to look for if someone put malware or if a new piece of code that you didn't drop into the system was put into that by someone outside of you or your company as well. That's another good piece that you can use AI to check for. So what I always say is start with what your challenges are and check if you need to validate for any of these things. And that's how to know if AI might be a fit. When you start to do this, what it does help with is promoting and enforcing consistency. Bots are extremely consistent in what they're doing. They're either consistent in being wrong if you don't train them correctly, or they're consistent in the output they're giving you, but they are consistent. It's also good to be able to get information and data faster. So they can do something in fractions of seconds that would take us much longer to do, and even is much more accelerated from what we see in traditional automation. So if you have an automation suite that traditionally runs in 30 to 45 minutes or to an hour, even depending on how many scenarios you're running through, the way that these bots are able to calculate and process, you can run through scenarios in minutes. So it's actually even more enhanced than what we've seen in the past on a lot of traditional automation in the speed at which it processes and is able to crank through scenarios too. So what you'll see, I think, is the example here that I'm showing why it's important. So anyone that's written coded automation knows that one of the always hard parts was for anything written off a game-based system. So if you were trying to automate off of what they utilize for game development and those types of systems, it wasn't possible. You can't code against that. It's dynamic. Things move around on the screen. You have no consistency with the images where things are going to show up. It's not like a traditional website or a mobile app. One of the places to go right away, if you're in anything that is using game-based systems developments or backends to gamify any of the mobile apps or websites you're working on, AI right here is a good way to do that, because you can see now it's running through and making decisions. It's giving scenarios to say, order a drink, and it goes through. And even if these pictures change, some stuff moves around on it, it's able to calculate and look at the fact that you see that dynamic background where fish may swim by or things will change on it. It doesn't get stuck or hung up on that. It keeps going until it gets to its result of, was it able to do its function or task of go from start to order a drink, right? So it's able to do that dynamically. Now, when you start to build this strategy around intelligent automation and AI, start with the challenges and issues you have today. So what is the challenge you're facing? Is it speed to market? Is it scale? Is it, I just can't do everything and I need help with this? But understand what those challenges are first, then understand your options and solutions. So understand if the best way to go about it is to build traditional automation. And that may be the best way based on a couple of factors. It could be based on the skill sets you have in your team. People have those skills and you have an abundance of coding skills, and it's fairly easy for you to be able to build and maintain that. But look at the maintenance tail and the cost on that, because you want to see how long it's going to take you to maintain it, not just build it the first time. And then what you want to look at is AI. And if that's actually a lower cost, lower maintenance option, it is less coding. So anyone that's looked into transitioning from building what would be traditional automation or coded automation using Java or JavaScript or any coding language, right? When you move into what you're going to do with AI, it is going to be less of that hardcore coding that you're building and more an understanding of how do you train algorithms? How do you optimize those algorithms in what they're doing? How do you think about the strategy by which they're built and the strategy of what they actually do and where the data sets are coming from? It's a different thought process that you think through and the way that you do it. So it is a transition I've seen for a lot of people as they move into that, and something to look at to see if that's a natural tendency for you. Some people I know who were in the coding space and have moved into AI really, really like it, because it's about optimization of how you build. So I would say just something to think about as you're doing that. And then before you get started, build that strategy. Consciously think about, what am I having AI do? What do I want to have automation to do and coded automation? What do I want to use humans to do? Thoughtfully thinking through and then shifting those as techniques develop and more tools become available. You're going to iterate and change that up. So I would say where a lot of people start is similar to when you start automation. You start with mostly manual and then you slowly build up more and more automation to where a good chunk of your work is automation. You determine what should stay manual, that's better to have humans do. And now you just layer in this third tier, which is AI, and you start with a piece and build that up over time. The other thing you're going to have to get really good at is metrics and dashboards. So understanding how all this data fits together and looking at how you want to analyze that data. As an example here, the types of things you get from AI that's really minute is you can run in production over and over again AI that tells you, if you ran a scenario of, let's just say we're going to a website and we want to take something from picking a product on a website to adding it to a cart, how long did each and every one of those steps take? You can get minute timings of what exactly happened, what gesture was it, how long did it take to move between each screen, and the minute that a developer puts in new code that changes those timings, even by fractions of seconds, it will be able to kick out and tell you something's changed and that you need to check and validate if you want to be increasing those timings or if that was too heavy on the website or the mobile app. And that could be things like images that are taking too long to load, all kinds of things that impact consumer satisfaction. It can also do these sample industry comparisons. So what I showed you back here, right, was these timings to get through one of these websites. But now If those websites are publicly available, Adidas, Nike, and Under Armour, you can run that same scenario through and in a matter of minutes, know where you sit against competitors. Now you know that if I'm Adidas, it takes me 11 steps compared to Nike's 8 and Under Armour's 6 to add a product to a cart. Do I want to do that, right? This is starting to drive product decision making, which is where testing is going, is helping determine revenue, product decisions, satisfaction of customers. What you can also see here really quickly is you get a lot of data to drive information and decisions, giving us things like it's taking almost 45 seconds to do this work on one website, whereas their competitors are less than half the time. And when you think about the demographic and the consumers that buy athletic footwear and shoes, one of their key components of why they buy on a site is speed and ease of use. So if you're taking longer and you're harder to use, you're not meeting what the demographic needs. So you should check your cart abandonment rates on this retail site. Just giving you examples of how this translates and correlates to decisions around quality, where you're very quickly getting information, not only on your own products, but competitive products by starting to leverage some of these new technologies around AI and ML in the space. And the last piece I would leave you with is this is also what's changing as we start to use more algorithms and bots. We become the relationship workers where the bots do some of the heavy lifting, where we leverage them to do a lot of the tedious day-to-day work that we would have done, a lot of routine checking and validation that humans would have had to do. When machines and bots are able to do more of that work, we're moving into this phase of our industrial revolution of humans are the ones who manage the bots. So it's our job to understand what they did. Was the outcome accurate and correct? It's not our job to just explicitly program. We train it, but more than that, we're looking at patterns and we're looking to see if the patterns in the data are accurate or if a retrain is needed of those algorithms and those bots. So what'll happen, and you'll see transition, is instead of humans managing other people, we start to manage bots who perform functions. So it's a new strategy. And one of the things that you'll see is a lot of our jobs get enhanced because it frees up more capacity or time. Instead of us having to do all the same things we did before, our jobs get enhanced and we get to focus on other things and we get some new jobs, but a part of our job goes away because the bots are able to do some of that tedious, repetitive work. And that's actually good. It helps us enhance as long as we as people move our skills along, right? So we have to continually evolve to keep pace and become continual learners. That's the piece here, is that we start to evolve and do some new things. This is one of those jobs, right? So it's a human machine teaming manager. It's a real job in companies right now that have lots of AI and bots, where people are managing bots or machines instead of managing just other people doing functions. You're managing sets of bots who are doing sentiment analysis and voice to text and virtual assistant and some of these other things. And then you're evaluating whether the output is accurate or not. But you need humans to evaluate that and understand if it's correct or not in terms of that. And what we do really well is what we have to keep doing, being creative, understanding how to be problem solvers, using our brains to do contextualized intelligence and relevance. Bots can't have empathy. They don't tell stories the way we do. And so our job becomes telling the story of the data of how we move the products and solutions and tech forward, but it's giving us the responsibility of those types of skills in our organizations to be able to move it forward. Bottom line, there's going to be some new skills we need to pick up. The pandemic has sped up the adoption of intelligent automation and AI in companies. They're going to be key competitive advantages to companies and will be part of the bigger strategy of how we implement process, intelligent automation, and innovation in companies. Anytime we've had in history financial crisis, pandemics, economic downturns, Constraint breeds innovation. Companies are looking for ways to get smarter and innovate and more optimal, right? So they're looking for ways to optimize what they have. And one of the ways to do that is to bring in these strategies like AI. So it's going to continue to be prevalent. It's about us taking the initiative to where do we want to put it in and how do we smartly add it in to our organizations. So knowledge is power and key. I'll skip to the back for you guys. I'm going to give you all of these slides so you have them. But my email is at the bottom. So Jennifer@redrex.com. One of the things I would recommend, two things actually. Coded Bias is a movie that is out. If you Google Coded Bias, it's available on PBS. Netflix had it for a period of time. It talks about the role of AI in tech and bias, and that's why humans are important and how we train. So I would definitely check that out as a resource to give you some more information. The other thing is a Coursera course. So the learner career outcomes after taking this Coursera course by Andrew Ng. A lot of people have said they've started new careers after completing these courses or got tangible benefits. They had just started a course, and I believe a new one starting shortly. They are free courses, Introduction to AI. If you have not taken it, it's a great place to get started. And I always recommend the big thing here is to inform yourself about it, because someone just asked the question. There's a lot of benefits, but there is disadvantages too if it's not applied correctly. It's very similar. If any of you have been a part of an organization who tried automation without a lot of knowledge, where you went out there and tried different solutions, you maybe tried open source, and then you tried some different technologies that were already pre-packaged and built. You maybe had limited success. Maybe you had an automation engineer that ends up leaving the company and no one else knows how to maintain it. Those types of things are exactly what can happen in the same pitfalls with AI if you're not going in strategically and informed. So you need to make sure that whatever you're doing with this, those 4 steps where I started with what's the problem you're trying to solve, and then sit down and look at your options and evaluate pros and cons. We actually at RedRex evaluate all these different techs and tools out in the market space. We create a massive grid of what they say they do, what they actually do, what problems they actually solve, to try and create openness about what technologies do and don't do right now, instead of just the marketing hype about what they are. And that's really important to us, is objective, neutral feedback for people on what this tech does or doesn't do, because you do want that. You want to know, does it actually do what it's saying? And right now, the reality is that most organizations will need to buy 2 or 3 different technologies to solve their problems in this AI space. It's not going to be a one size fits all for most organizations, because there aren't full scale solutions. You need multiple techs to do what you're trying to accomplish or do. So getting help, asking questions, finding a trusted advisor or resource, incredibly important in this journey, to not have some of those pitfalls or spend a lot of time, effort, and money and not net out a lot of result. So we are at our time. I appreciate you guys. Hopefully that answered your questions. I know many of you probably have to jump. I am happy to stay on and answer a few more questions if you guys want to stay on and ask them. You can also email me too. You can connect with me on LinkedIn also. We just scratched the surface. This is a really big topic. So, so one of the things I would tell you is get information and look at resources to get many different sets of information on this. Oh, are there efforts where it's substituting totally or at least partially QA engineer efforts or human beings? No. So what I'm seeing smartly in a lot of cases is thinking of it where this was very similar to, I think, a lot of the fears initially when automation came out, that we would automate away all the jobs and all of our jobs would go away. And that still hasn't happened. There are definitely tasks that automation's more adept at doing, that it's done, that we don't now need to do. But where I see it more is taking those heavy, repetitive tasks off the plates of testers and assisting so that you have more bandwidth to actually achieve the more complex functions that we need to think through. So user flows, different types of tests that we don't have time for on all different operating systems, versions, form factors, making sure all of that is fitting, that data isn't truncating, those types of things. AI is very good with some of those functions, so you can focus on other things and looking at those. But I think what we're seeing right now is I call them your virtual assistants. And all of us could probably use some virtual assistants every day because we don't have enough hours in a day to physically do all of the things we want to accomplish. And that's where I think testers taking an active role in this strategy is important. And you taking an active role and not letting someone else dictate it onto you. I think that happens a lot with new strategies, is the business or another team will come and say, here's what we need to do. We're going to start using this to test all of our website or our apps. I think we as testers in the organization need to be at the forefront of how we could use it to help and assist the organization. How do you sell it to the customers, and any real life examples? Yes. So what I would say with that is I have some examples of that sentiment analysis. It's a great place to start because customers as in our business folks that we work with that utilize the tech and deal with our customers, love to know information farther up front. The other thing that I think really helps us as testers, AI has the capability to do, and we barely touched on this, app graphing, where it goes through an entire application and it graphs all of the places different fields are utilized, all of the interdependencies, all of the different nuances, so you can visibly see risk in terms of if a field breaks or if they add something new here, this breaks all these other places. And it does that automatically. So in a matter of minutes, it's running app graphs for us every time there's a new build. So one of the challenges for testers a lot of times is we don't know what's changed, right? And we'll be told we didn't make a change, nothing changed. And then you look at it and you're like, no, you changed something. You clearly changed something. And they're like, no, nothing changed. But this gives us the capability right away to know that something changed and what changed, and go back and say, here's what changed through that app graph capability. So 2 areas where I see it being really impactful, really easy to set up and start right away is creating app graphs, and then also sentiment analysis are 2 nice low-hanging fruits to start with this that provides almost immediate value for you in an organization as a tester for AI. And I have some examples of those. So if you guys email me, I can send those out so you can look at them as well. Perfect. All right, and I know we're over. I didn't see any other questions. You guys are able to email me and then tell Victor if you want a follow-up session, we can dig deeper on sentiment analysis and app graphing, so I can explain how that works too with AI. And then also if anyone's interested in learning about different tools out there, some of the use cases of where you would use them depending on the challenges. We have a little graph that graphs that too. So thanks everyone. I appreciate you spending the time with me. I hope to hear from you. Email and have a wonderful rest of the day. If I didn't answer any of the questions, just ping me and I'm happy to answer them for you guys. Thanks everyone.